everyone to today's webinar, Inventor Advanced Assembly. My name is Joy and I am part of the team here at NexGen. I'm excited to have you with us today. So before I hand things off to Eric, a few things I just wanted to run through with you. If you have any questions that come up at all during the webinar, feel free to use the Q&A feature at the bottom of your screen controls and drop that question there, and we will get to that at the end of the webinar. And then just kind of who we are very quickly. So NexGenSolutions is an Autodesk Gold partner. We specialize in the design and manufacturing space. And originally when we started, we were NexGen Cam, so we had a deep specialization in the kind of the cam arena. And as we grew as a company and with our customers, we've now expanded to solutions for design and manufacturing. So you'll see that because of that deep kind of well of CAM knowledge, we've been the #1 Autodesk CAM partner 6 of the last 7 years. And earlier this year, we were recognized by Autodesk as their #1 service provider in North America. And so we were completely excited, stoked about that, and have no plans on letting that title go. In addition, we are also an authorized training center. And if you've been around with us for any length of time, you know that training is really important to us. Services that the software is great, but it's only great if you know how to use it. So in addition to all the training classes that we offer monthly, weekly, throughout the year, we also try to have a lot of webinars like this to share new information and ideas, products, and solutions with you. So just here are a few of the things that we have coming up. You can always find all of these on our website under events. And today, if you were interested in learning more about Inventor, we have a lot of training options available to you. You can find all of these classes and more on our website as well under the training tab. And with that, I will pass it over to Eric.
Hey, thanks, Joy. So my name's Eric Miller. I'm the Technical Solutions Manager here at NexGenSolutions. And my specialty is kind of in the more design and data management side of the business. And so that includes, a variety of tools like Inventor, Vault, Upchain, AutoCAD Electrical. So those are the things that my team helps support, train on, and also, kind of provide, pre-sales demos, things like that. But and just, working with customers to make sure that they're trained and ready to use those tools. So I'll share my screen quickly here, and let's see. Just wanted to touch on a couple of the. So yeah, the topic today is advanced assembly, and I'm actually that's a pretty wide, range topics. I think we're kind of going to do sort of a series of these things, and what I'd like to focus on today is kind of the top-down design methodology. So if you're not familiar with that, a lot of times that top down or bottom up are sort of two methods of approaching a product design. And what I've found over, I've got, I guess my background's in mechanical engineering, been doing this for 20 some years, either on projects or, working with not just Autodesk software, but a variety of other CAD tools as well. Is that it's usually kind of a hybrid. It's usually a little bit of both. You don't always get a chance to start with a clean slate. But when you do, it's actually pretty cool because you can kind of use a little bit more of your imagination and kind of think outside the box and those kind of things. So, but just, to touch on the top-down design is kind of where that comes into play a little bit more. So, top-down means we're starting sort of clean slate. We're going to kind of think about what components we might want in our design and typically use sort of a skeleton as the foundation for that within your assembly. And then kind of, we're going to store a lot of our information and our, kind of the framework for our design in that skeleton, and then propagate that information down to the components underneath it. So it's really kind of a high level to start. And then as we start to propagate information, maybe it's surfaces, maybe it's sketches, maybe it's, other datum work planes, work axes, things like that down to our piece parts, we can really kind of control multiple components from just one skeleton. So that's kind of the advantage we talk about with top-down design, is that you almost have this sort of puppet master skeleton model or file, And as you make a dimensional change there, change the design a little bit, you can propagate, those design changes much more quickly down into your components. So the advantage there is you don't have to open up 10 different components to change the same dimension on each one. You change it at the highest level and let that then information then just flow into your components. So I'm going to touch on that just a little bit. We'll go through sort of a simple example. And, I just wanted to touch on some of, and so I guess, that's top-down design. Bottom-up design is typically where you're, designing something and all the parts, or maybe most of them, are kind of already out there ready for you. So I worked in in a construction equipment business for a while, designing excavators. And, that's a business that had been, going on for 60, 70 years already. So you can imagine there's already a good chunk of designs out there that we're not going to just reinvent the wheel each time. So we'd use maybe a pump, or use a valve, or maybe use a portion of on an excavator, like the upper structure, undercarriage, things like that. You're not going to just redesign that every single time. You're going to take things from previous designs. Maybe you're going to make them better, but you're usually starting from something. So that's more of that bottom up type of design, where you're not just kind of free, it's almost like you're not starting from that bar napkin sketch anyway. But what I've found is that a lot of times it is sort of a hybrid there. Like it still works well to have a skeleton, even if you're bringing in, outside components. So anyway, a couple of the challenges just to think about how this can apply, and maybe the situation that you're in with your company, is obviously it's nice to have some flexibility. As you're designing, things change. We might have a decision. You're trying to, trying out a specific design and decide, you know what, that didn't work out well, or maybe I did some FEA on it. We need to add a little bit more strength here or there, or take it in a different direction. So you want to be able to be flexible with your designs and not have to go down a one-way street and hit a dead end and then have to start from scratch. So I think that's one of the things top-down design can kind of help with too, because again, it's easy to shift gears, adjust it on the skeleton, and then not have to reinvent each part underneath that. They can kind of rebuild with those skeleton dimensional changes. Collaboration, this is another area that oftentimes is difficult. If you're not using a data management tool right now, that I would suggest looking at that to help with collaboration. We don't want to be saving over the top of other people's files, things like that, being able to know who's working on what. So a PDM tool can really be useful for that. So if you're using Inventor, and you're in this webinar, Vault is a great tool, but then there's also a new one called Upchain out there that can help with collaboration. But that's kind of more just from the, file management side. When we actually talk about working on the same designs in CAD, that's where kind of the skeleton and the top-down method can kind of help with that too. Maybe you have multiple skeletons in a particular assembly. You're manipulating one, or maybe that one skeleton is driving multiple parts underneath it. Well, at that point, then maybe, a few different people are working on some of those subcomponents, but all pointing back to that same skeleton. So it does help with collaboration as well there. If your coworker makes a change to the skeleton and wants that to update your parts, you can make those links and connect them or disconnect them when you're ready to release your model. I think that's one of the things I typically encourage, designers to do, is when you're finished, the top-down design works really nice on the conceptual side and kind of getting your design towards that production goal. But then once you reach the point of we're going to release this out to production, you have to kind of think about what might change in the future. Who is going to be working on this in the future? Are they going to be aware of these interdependencies? So sometimes it is best to go through and then break some of the dependencies, maybe turn off the adaptive. We'll get into that a little bit today, within Inventor. But just to make it a little more robust and not have, one person change a dimension, not realizing everything else it's affecting. So there's some risk there, but it can be really helpful throughout the early parts of the design up until that time you're ready to release it. Obviously, scope changes, that happens a lot too, right? If you're on a longer term project, things get, your customer might want one thing one day and a different thing the next. Development time is a big thing. Time is money. We're always, as designers and engineers, we're always pushed to meet deadlines, if not exceed, or meet that even earlier. So, if we can kind of shrink down that design time at all. Typically that just means better, better performance as a company. You get the product to market faster is always a good thing. And obviously we want high quality products as well. So, and one thing that can help with the time in development is to add some automation. So that's another challenge I put in here is, one of the things we try to do is make sure that our designs are not just, redoing the same thing, trying not to, add extra work into it that isn't required. So anytime you can add, when there's symmetry involved, when there's ways to automate a process, Inventor's pretty good at doing that. There's a tool built into Inventor called iLogic that kind of takes, sort of takes a sort of a coding, app development sort of approach, but it makes it into designer, terms that designers and engineers are familiar with. So it's really easy to learn. You can do a heck of a lot with it, but I think if you've got any repetitiveness in your designs or maybe different versions, or you want to be able to add some rules in there, that's really what iLogic is about. Adding some rules, some conditional things where if this dimension changes, so it kind of blends well into, using a skeleton and driving different parts of the model, you can use iLogic to kind of, almost add a little bit of extra horsepower into something like that. So, just you can actually build a form that pops up with iLogic, enter in your criteria, whatever parameters are required, and then just let your model rebuild from that. And, if you take it a step further, there's actually, with iLogic, you can bring those Inventor models into a design automation website, actually. So using Forge is Autodesk's cloud-based development platform. So Forge, the recipe is already actually out there. You may have heard of Config 360, has been around for a while. That's getting discontinued or kind of end of life coming up pretty soon. So Forge is really the new path to take your designs that have some iLogic automation built in, bring those into more of a cloud-based tool that you can pop open a website in front of a customer and have here choose these selections, and then just build your model right there and actually generate your parts, your drawings, RFQs, whatever it might be, right from that website. So that's the recipe is out there to be able to do that. I think that was kind of the transition. Autodesk kind of said, hey, we've got to have something good that we can provide if customers are going away from Config 360. So that's kind of the tool that's out there, and I can maybe show that on another webinar at some point. But and then just I put creative control in there too. I think when you get a chance to start from the top level with a clean slate, which is kind of top-down design, you really have the chance to utilize your creativity as a designer, as an engineer. I think that's sometimes gets lost in today's world. You just go through the motions. You're creating drawings, you're adding dimensions, but when you get a chance to actually kind of think about, let's create something that's never been created before, that's pretty awesome. I think that's why we kind of went into this business probably. So creative control is always nice, and if you're using the top-down design method, you probably have a little bit of that. I think that's a term that's typically used in movies and stuff like that, creative control, but I think it applies kind of nicely too on the design side. All right, anyway, let's take a look at Inventor here and just talk about how a top-down design approach would work. And in this case, this is an example. If you've been in my classes before, you've maybe heard me talk about building a wheelbarrow. It's one of those, everybody can kind of say the words wheelbarrow and kind of envision what it looks like in your head, right? So how do we start from the vision in your head to actually build something on screen here? So that's what CAD is. We're taking it from a concept to actually building a digital prototype. And that's what these CAD tools really are, is they're digital prototypes where we can design them, we can test them, we can do simulations, we can do all kinds of stuff before actually building it, and try to prove out our design before it gets to that point. So we look at that as a real physical kind of model, a digital prototype on our screen. All right, so let's start with, again, better keep an eye on time here. Okay, we got 15 minutes left or so, and then we'll try to take some questions on it. And hopefully, again, this may not be new to everybody, but I'm going to just start with a new assembly. Sorry, that's coming up on the other screen. Again, blank slate. So I'm going to save this right off the bat here, and we'll give it our name. So this is going to be Oh, better put it into the appropriate. So I'm using Vault here. And if you're, again, with Vault, we synchronize from the Vault server down to our local C drive. So that's one of the advantages there of Vault. I'm going to start a new folder here, and we'll call this wheelbarrow. And this is where I want to store my design. So my initial assembly, we'll just call this wheelbarrow. And maybe we'll say, you know, give it some kind of cool name, 2000, something like that. Like it's this brand new wheelbarrow that nobody's ever seen before. All right, so we're going to start that. And what we do next is kind of, so there's not a separate file type for skeleton files within Inventor. So we're just going to use a regular component. But if I go create here, so up on top, sorry, some of these are skipping over my other screen. Slide that over. And then we just got to think about envision. What are the different parts that we need in a wheelbarrow? So we actually, you know, first, before we do that, we want the skeleton. So let's just call this one wheel. So we'll just go SKEL for the skeleton file. And if you look at the different part types, you know, we've got an IPT here. This isn't going to be sheet metal. So I just typically leave this as a regular IPT, even though my skeleton is probably not going to contain any real physical geometry. We're going to put in, you know, as far as an extrusion, things like that. We want to just put in some of those higher level things. We can use surfaces. I usually like using that as a nice way to create space claims, things like that within your skeletons so that you can use those, reference those in other components, sketches and things like that. But notice too in the bill of material, the different types here, we're going to stick with normal. There are ones like reference that we can utilize, phantom, purchased, that kind of help when sort of breaking down your bill of materials into, you know, what needs to get built in-house, what needs to get, you know, brought in, and what things are maybe, you know, kits or something like that, that maybe they're just organized differently. That's kind of where the phantom is. But typically reference could potentially be like a skeleton file, so you can remove it from the BOM. But there's also a virtual component there too for that checkbox. That would just be more like oil or grease, the things that don't necessarily have, you know, a geometry built into it as well. But I'm just going to leave this one as a normal IPT. Okay. And when we're just creating these parts from scratch, we're just going to kind of drop them in, and at that point, then it's activated. Notice over, and I have my Vault browser right next to my regular browser, so it activates that part right away. And you can see it kind of pinned it there where it's at. So let's what we want to do is actually ground that to so that my origin planes kind of match up together. So if I go up to my productivity panel here in the assembly tab and go down to, we want to ground and root. There we go. So ground and root that component. And we're going to select the wheelbarrow here. And oops, the dialog boxes keep going over my other screen. And we can reposition at the top of the browser font, but we don't need to do that. So I think we have it selected already. Let's hit apply and cancel. So now that one should have moved it. And again, we're not really seeing it unless you turn on your datum planes. So obviously by default, those are all hidden. But here you can see those, and I can just kind of verify then that, okay, that one's matched up. Oh, actually that is not matched up. So what did I do wrong there? Ground and root. Oh, sorry, place. I think I used the wrong one there. Place component at origin. Is that the one that I want to use? It's going to undo that one. Okay. Let me see here. I wonder if I don't have to have that one. It should have really actually grown in. Unless it just didn't. I was thinking ground and root actually would take care of that. Provides option. Flush constraints, yeah, with the origin. Okay. Maybe it just wasn't selected potentially. There's still something going on there that's not quite right. I apologize for that. But nonetheless, I mean, why wouldn't that store it? Productivity. Unless it was fixed to begin with, maybe that was part of the issue, grounded. So now let's try that. I think it might have had that on there, to be honest. Hey, I think that did it. Okay, yeah, sorry. So I thought I saw that in there too. If it's got the pin, when I dropped it in there, it must have grounded that initially because it was my first component. That's kind of what happened there. So you have to unground it, which is right here, and then allow it to ground and root. So that allowed it to now move. So my component now has the same, basically lined up with our coordinate system and all our default datum planes from the wheelbarrow assembly. So that's kind of key. But yeah, so this is where we're going to put in a lot of our, details that we're going to bring into other components. But if we think about now just building out some of my bill of material just from a blank slate here, let's put in another one. And this is going to be, we'll just create another part in here. We'll just start the wheel. Well, maybe we'll build up from the ground up, start with the wheel, hit OK. We'll drop that one in. I'm going to go, let's just go right back to activate the assembly. We'll go create. And let's go, the next one would be maybe the bucket. All right. We'll hit OK and drop that one in. We're going to ground and root all these ones as well. So I'm just dropping them kind of into space. We'll go back, activate the assembly one more time. And then the last one would maybe be my handles. And we'll say this, maybe the handles are connected. So, so those, when you think about a wheelbarrow, those are kind of the three main components, right? So we'll drop that one in, activate the assembly again. And now you can see the little circles next to that. The black circle next to our components means it's fully defined. So that's locked in. The other ones here can still move if they've got the white circle. So we're gonna go ahead and ground and root those as well. And so when you think of this process here of, top-down design, a lot of times what happens if you're starting with blank components, it's like you don't really know where the mates are going to be, and just verifying they're all lined up now. So even though now we lined up the datum planes initially, some of the geometry might then be a little bit further away from your your default, your work planes. So the X, Y, the Y, Z, the ZX plane. So those, it's maybe one drawback of this approach is that most of the time your geometry might not be right over the top of your kind of default origin work planes, but it's really not that big a deal. It kind of allows you to swap things out easy enough by doing that. And the nice thing is all my components are going to be lined up flush with those, robust work planes, the origin work planes that really are never going to change. So we know that our initial, at least assembly of these, it's not, they're not floating or anything like that. You can obviously remove some of the constraints here eventually to allow some motion, things like that, if you want the wheel to spin or whatever. But we're going to start with this. And so again, we're just looking at a blank assembly. I know there's nothing on my screen yet. Obviously, if I, show some of my planes, turn the visibility on there, we'll see they'll all be kind of lined up on top of each other. Right. So that's where everything's at. All we have is planes out there right now. I'll turn the visibility off there. So now basically what I want to do is start building some geometry into my skeleton file. So I can just open that up on its own and then start building out, okay, what are we thinking this is going to look like? So one of the things I like to do, especially if you're kind of working with, something that's sitting on the ground, is to kind of rename maybe our XZ plane here just to ground. So I'm going to go, I can just click on it there. And we'll just call this ground so we know kind of where we're starting from. We'll work our way up from there. And you could turn the visibility maybe on for that. Okay, so there's our ground plane. And let's just drop in some sketches maybe to start. So I'm going to sketch on the XY plane here. And we know this is our ground plane. So again, we still project geometry, things like that. But let's say we just want to, drop in here what our wheel is going to look like. Okay, so if I just kind of snap that into position, again, this is just going to be a sketch here. We give it a diameter of, let's say this is a 12-inch wheel, something like that. Hit OK there. And I think I might still be, yeah, it's not quite locked in. I probably should have projected also a vertical plane. There we go. And then we'll just line those up. We'll line up that middle point with that one. And now once it turns black, obviously, if you used Inventor, you know that now it's fully defined. And that's really what you want to do in your sketches. Definitely a best practice. Don't leave things purple, blue, whatever. Try to get it locked in, especially if you know what your design intent is there. So we're going to hit OK there. Okay, so that's just kind of an initial part of our sketch. And I know I'm not going to have a ton of time here, but basically we could even add a surface to this if we wanted to. So if you like to sort of see this built out into more of a, you know, physical to sort of see what it looks like. I don't like, again, putting solid geometry in my skeleton. So as I'm building, sorry, this is came to the other screen also, there's a little option up on top here just to turn surface mode on, surface mode. Okay, so now this is actually acting, there's basically surfaces are kind of zero thickness. And when you get into surfacing, you know, that's another kind of more we touch on that in advanced part class, where you can kind of manipulate, you know, surfaces, you know, patch them together. You can really create some unique shapes. So in the automotive industry, some of those other higher end where you need the aesthetics are really important. That's where surfacing comes in, and eventually maybe you thicken it or shell things out, things like that, to be able to get nice smooth shapes, but able to still manufacture them. So again, that's kind of, again, if you're interested in stuff like that, we'll talk more about that in a later webinar, but I'm just going to make this one, oops, let's see. I mean to I grabbed a different surface there. Let's see, profiles. Let's cancel that one out there. I'll grab this one. Okay, equidistance. Then let's say this, maybe it's 5 inches. Okay, so then we can kind of see what our wheel is looking like, even though, you know, it's not necessarily in our model yet. Let's just do maybe another quick one in here. You know, and again, in the skeleton, we like to add a lot of these work features. Okay, so maybe I want to put in, let's put in an axis through that wheel or through that surface. Okay, there's our axis through the wheel. And now I maybe want to add a plane from where my handles are going to go. So let's start a plane here. We'll go through that one. I'm going to hold control and pick this bottom one. Now we've got sort of an angle here. We can put this one maybe at like 35 degrees and use this for, you know, creating my handles. Let's hit OK there. And again, it's always good to kind of rename these things so you know what they're used for, instead of just extrusion one. Let's say that we can call this one wheel. Work plane one. Let's call that one handle plane. You know, so try to take advantage of that, so it builds a little bit more intelligence into it. So the next time either you open it a year down the road or somebody else, you really get a better. You're not just kind of, you know, shooting in the dark there as far as what each of these are really for. And if you touch on these here, you can kind of drag the corners and just drag these planes up. So it kind of takes the shape of your part. But now I can kind of see, okay, my handle, I'm expecting that to go up to the right. All right. Let's add one more sketch, and we'll put that again on XY plane. Now we can kind of maybe start sketching out our, let's see, let's project some geometry first. Project the wheel and the handle plane, and then we can start building, you know, what our wheelbarrow is going to look like. So snap it to that. Come over here. Come down like that. And then maybe I'll just connect these two. And so where this can kind of help now is I can put, you know, for my skeleton now, I can make these two. Oh yeah, that's right. You gotta, if you ever done these dimensions to a tangent point, you really gotta, you can see the glyph changes there a little bit. You gotta hover over that spot, wait till the glyph changes, and then now I can create my dimension between the two. Let's say we need that to be 1 inch. And so as my wheel changes, maybe diameter or whatever, now this is always going to make the bucket at the right spot. So it's always going to be 1 inch away from the wheel. We can add a couple of other ones in here to say 35. Let's put this at a specific angle here, 35. And then maybe overall height is maybe another 1.1 from the base plane there. Let's say we want this to be 26 high. And let's kind of go for maybe the center here out to this one. Let's make that one 15. Okay, so now we can see it's fully locked in. Obviously, we're worried about maybe center of gravity over the top of our wheel, things like that. We can kind of finish out our design eventually, but just to have that available now, we can even use maybe some planes or even create a surface with this one potentially. So if I go extrude, grab that profile, and see now it's got surface selected. Okay, so let's just drag that out a certain depth. and hit OK there. So you can really, it's like we're seeing the wheelbarrow barrel, envision, the vision we have for it is already, right here, even though haven't really put any geometry yet into our parts. So the way we do that, that's kind of the next step, is once we kind of get this finished out the way we want, this is like our puppet master high level. We're going to drive the design from the skeleton. But now I go back to my my assembly here, and we've got the the bucket, the handle plane, and the wheel. And so just to kind of show quickly, I know I'm kind of getting up probably against, I get kind of talkative when you start going through these things, but now what I want to do is activate the wheel, kind of right in context here within my assembly, and I can utilize some of this geometry and kind of just reference it so that it drives my wheel creation. Okay, so let's sketch on. We'll start a sketch here, and we'll put that on you can see that's kind of pretty small down here, but eventually it'll take the shape of our design. So we want to sketch on that XY plane there too. There's my plane. So it's kind of hard to see since we're looking at it at this angle, but let's project some geometry here. And there's the wheel. Okay, so that's really all I need to project in order to create the wheel in the part anyway. So let's hit there. Okay, we're going to extrude that. And again, let's go just maybe a distance of 5, both directions. Hit OK. And let's, again, one of the key things is to typically, I don't know, my materials are not showing up in there. I wonder if that's okay. But let's maybe just add a couple fillets here to make this look like a little bit better wheel. Maybe 1.5, something like that. And now if I open up the wheel on its own, and we see the geometry here, and see, must have an issue here with my material library. I did just switch some things around in my project file, so it's not pointing to that. But obviously, we want to make sure we apply the right material. So I was just going to apply rubber to this wheel. We maybe put a hole through it. However, we're going to connect in with our handles, things like that. But you can see how the design can kind of get started. And notice here now, this is our adaptive icon that shows up next to this extrusion, meaning that it's referencing something outside of itself. Okay, so there's an external reference out to our skeleton, and again, we go back to the main assembly here, and then just hit save on that. Make sure everything's saved here, and that's kind of we're off and running here. And again, it shows the adaptive icon there. If you ever want to break those, it's a little bit of a temporary break because you can always turn it back on. But if I uncheck the adaptive, then it's not going to be driven, at least for the time being, by the skeleton anymore. So that's one way to kind of break that link. If you really wanted to break it, you would probably go in, you'd have to go into the sketch that created the wheel, remove that projected, it's basically like a constraint that projected from that previous skeleton sketch, and then just give it a regular diameter and lock it in with respect to the datum planes, right within the wheel part. But throughout the conceptual side of this, it's nice to have that adaptive external references going back to the skeleton, because they all just get, they all are going to move based on any dimension changes I make in the skeleton. So probably not anything too groundbreaking there. If you haven't, if you've worked in assemblies and Inventor quite a bit, you maybe used a little bit of this already. But I think it's a good concept, the top-down design concept. If you get a chance to utilize that, try to take advantage of a skeleton, use it to help propagate information down to your piece parts. Okay, well, let's take a look here. If there are any questions, I'm going to bounce back to screen. And not seeing anything in the Q&A dialog box. So just want to say thanks everybody for attending. And I'll just, I guess we got to the questions. I'll just say thank you there. And yeah, tune in next time. We're going to try to do a series of these at least once a month for some best practices utilizing Inventor and potentially Vault. So, keep an eye out for those, and as well as a lot of other content coming out there too in the CAM side and, design and data management. So Hope everybody has a great day, and we'll see you next time.